Hi, in this notebook, I am demonstrating the TensorFlow high-level API version of a basic neural network for nonlinear regression. This part of my deep learning assignment where I have to build multiple variant of the same problem. In this specific notebook, what we are using is a TensorFlow model subclassing. The goal is to predict a nonlinear target value generated from three input variables using a three hidden layer neural network. So let's go ahead. So we can see in the first markdown cell explains the what is the purpose of this notebook, and here it is described the synthetic nonlinear equation used to generate the data, and also the equation includes on the sine, quadratic, and cubic terms and everything. And let's go to the first cell, the code cell. In this cell, I install the required libraries like a TensorFlow, scikit-learn, and matplotlib. TensorFlow is used to build and train the neural network. Scikit-learn is used for train, test, split, and PCA, and matplotlib is used for plotting. Next is data generation cell. In this section, I import, as we can see here, NumPy, Matplotlib, and utilities from scikit-learn. I also get fixed a random seed so the results are reproducible. Next, I define a function called makeData. This function creates a synthetic data for nonlinear regression. X1 is sampled from a uniform range, and X2 is sampled from another range, and X3 is sampled from another range. Then the target y generated using the nonlinear equation. So instead of using a real dataset, I am creating my own control dataset where I already know the input output relation. After that, I combine x1, x2, and x3 into the future matrix X, we can see here, and then reshape Y into a column vector. Then I split the data into a training set, validation set, and test set. Training set is used to fit the model. Validation set is used to monitor generalization during training, and the test set is used for the final evaluation. Finally, I print the shape of all these three data set, which is training, validation, and test data set, and to confirm the split is correct. So we can see the split here. Next is 4D style plot explanation. In this cell, I create a 4D style visualization of the synthetic data. Since the input has a three variables, um, what I would do is, and the target adds one more dimension, the data is effectively four dimensional. To visualize, I use a PCA to project the three input variables into 3D space. Then I use a color to represent the target value y, so that the x-axis is PCA1, y-axis is PCA component 2, and then the z-axis, we can see PCA1, and y-axis is PCA component 2, and the z-axis is PCA component 3, and the color shows the target y value. This gives a 4D style plot where I can visually inspect the structure of the nonlinear regression data. Next, this is the main model definition section. First, I import a TensorFlow and again set the TensorFlow random seed. Then I define a custom class called subclass regression model, which inherits from tf.keras.model. This is called model subclassing, and it is one of the high-level API in TensorFlow. Next, inside the constructor, I define the layer. First, dense layer with the 32 neurons and ReLU activation. Second layer with the 24 neurons and ReLU activation. The third layer with 16 neurons and ReLU activation. Finally, the output layer with 1 neuron for regression output. So this is a three hidden layer neural network. In the call method, I define the forward pass. The input goes through the first hidden layer, second hidden layer, third here layer, and finally the output layer. After creating the model object, I compile it using Adam Optimizer. Here, Adam Optimizer with a learning rate of 0.01, mean squared error loss, and mean absolute error and additional metric. Since this regression problem means squared error uh, is an appropriate loss function. Okay, next in this cell, I train model using model.fit. The training data x train and y train, and the validation data is xval and yval. Yval. I train model for 250 epochs with a batch size of 64, and y verbose 0 so that the notebook output stays clean.